Broadcast is now starting. All attendees are in listen-only mode.
Welcome everyone. Thank you for joining us for today's webinar. My name is Mohammed Al-Abbadi and I am the project sales manager at Danfoss. Danfoss is the leading provider for hydronics and balancing solutions. Today we are presenting Novocon Smart Actuator Delta T Manager, and we will highlight the benefits and features that will increase the efficiency of the cooling system. This presentation will be presented to you by our regional technical manager, Anis. Before we get started, if you have any questions during this presentation, please type them in the question box in your control panel. We will have time approximately 15 minutes for question and answers at the end. I hope you will enjoy it and it will be useful for everyone. I will leave the word to Anis now. Hi, Anis.
Hi, thank you, Abadi. Good morning. Thank you for joining us. So we already discussed the mechanical part of the valve, which is pressure independent and control valve, in our last webinar. Now we will talk about the actuation, because there is the traditional actuation, which is a normal gear motor, printed circuit board with dip switches to achieve a certain functions. Now we will go to the next step of the actuation, which we call the smart actuation. So in this presentation, we will have short introduction, what is the Novocon, how to select it, how to adapt it, and so on. So since long back, we came up with the PICV concept, and I will not say we perfected the PICV as Danfoss. I would say we know about what the PICV should be and how it should work. So that's why we designed the most optimum way to operate a PICV. There is a different technologies, but we believe that we try to minimize all the risk, all the problems in control, system service, etc. And that's why we went to the next step, which is the actuator. So based on the building process, based on the data from the buildings, the higher demand on both comfort and energy efficiency, we invented the Novocon. So it is not something that we are trying to promote because of it's a Danfoss product or something, but it's from the need of the market that we were receiving during all these years of expertise. Sorry. So Novocon is an electronic actuator which can give us these features: bus communication through BACnet, MSTP, or Modbus RTU, flow indication, data logging through a trend system from the BMS, which means usually an actuator will receive a hardwired control signal and will give you a feedback signal in terms of 0 to 10 volt or 4 to 20 milliamps. In case of the smart actuator, every single variable inside this actuator can be addressed, and you can read it or you can write it or both. So what will this give you an extra is the flexibility to design your sequence of operation based on what is the load demand and what you want to achieve in your system. Let's say during peak summertime, you need maximum flow, maximum cooling capacity. Actuator can be programmed to override everything and to provide that. And during part load condition, you don't need that much, and you can achieve the same comfort level with even higher supply temperature. You can also program that in the actuator. So there is no more need for an operator to stand there reduce, increase, change the variable, etc. This can be programmed once and the actuator will work automatically. So if we take normal communication in a BMS system, you have your valve, which is here at the right, with a normal gear actuator. Those are Danfoss. Then you have the controller to control the unit fan and to give the control signal. And then you have the BMS. Now, in case of Novocon, as we said, it has its own control logic, which means you can use any variable inputs and outputs to control based on the room temperature, based on the return temperature, based on any variable you need. So there is no more need for this controller in case you are using an EC fan motor. EC fan motor is a motor that will work with 0 to 10 VDC command to change the fan speed. So if you have that in your system, then you only need the Novocon, BMS, and the unit. How you will change the temperature set point, this is an IP accessible address, then you can just change it via your mobile by accessing the IP address of that unit specifically. So this is, if we take as material itself, this is a really big saving in the initial cost if you are using again an EC fan motor, not the normal traditional 3-speed fan. So in the Novocon, as we said, the addressable actuator, we will have BACnet Modbus data communication, 24-volt connection, daisy chain from the two sides, analog input and output in the middle, temperature sensor, wired or direct sensor. So you can have either the provision for a PT1000 sensor or you can have the PT1000 sensor directly. So we will see this in detail here. It's based on your application. Sometimes you don't need that, sometimes you need it. You need the actuator, you need the daisy chain, because the daisy chain, which is the looping cable or the looping wire, will carry the communication wires and the 24-volt. So the middle wire will be an optional in case you want to boost the power and to use analog local control, because when you use a smart actuator, you can use digital remote control from BMS, and some cases they need still the local controls hardwired, so it is also available there. So you can go with normal analog cable or with analog cable with built-in temperature sensor. We will see the usage of this later on. So in details, if you cut, let's say, the daisy chain wire, you will find a red, black, green, and then white green. So red is 24-volt, black is ground, non-inverting, and inverting signal of the BACnet or Modbus. So in the middle cable, which is having most of the functions, you have the power booster, because after some number of actuator loop, you need to boost the power, because voltage will drop with wires because of the resistance itself. Then you need to boost it. Then we'll have the blue and the gray, which are the input signal. And then you have the white, which is the feedback signal. The gray is the ground for all these. And then you have yellow and orange, which are the PT1000 temperature sensors. Now, what we can have, some of the features that we can have from the Novocon actuator. Automatic calibration, for sure, this is something that we are having also in our traditional normal actuator. and it is required to match the setting on PICV. But in case of Novocon, we see that you don't need to set it mechanically, so you don't need to set the valve mechanically. You need to know what valve size and stroke length. That's why the automatic calibration is there. Also, another important feature of the automatic calibration is that in case the actuator is not somehow fixed properly on the valve, with this automatic calibration feature, if it will not happen, you will have an alarm that the actuator is not fixed on the valve. So this is very important, especially where you install the valve somewhere that you cannot access or you don't know about it. Once you have everything communicating, you will have this option. Setting the size, we will see that also. Setting the maximum flow. So if we take automatic calibration, it's very simple. First time you energize or when you hit the reset button, it will go to full close, full open to know what is the total modulated stroke length. Assigning the size, this is based on the application. So in this case, you can put our valve model, A, B, Q, M, D, N 15, and so on, but this is also more flexible. You can name this actuator and valve any name you want. You will find in the list, like you see the sizes of the ABQMs here, you will find at the end user defined. When you put user defined, you can put any name, let's say FCU ground floor shop number 1 or FCU bedroom or living room, anything. So it's flexible. It shouldn't be the size, the ABQM size itself. Remote flow setting. This is a very nice feature, I would say. Instead of doing the manual presetting, which leave more error to human, remote flow setting will remotely assign the maximum flow that will be modulated. So in our case, valve is DN15 with nominal flow of 450. The setting of the flow here is 225, which is 50%. So once you have this, you just feed it into the actuator, and then it will limit to 50%. Now the 10 volt or the 100% will be that 50%. So why we say this? Because since you can do this for one valve actuator, it can also be done for the whole loop. Which means if you have a loop of 32 actuators linked in one floor DDC, then once you access in the BMS, we have a tool which is called Danfoss configuration tool. Having this tool will allow you to make a CSV format. The CSV format will look like Novocon ID, which is unique to every Novocon. So you have your IDs in your loop, front of it, comma, then you put your flow rate. Once you're done with it, this is also done by Danfoss, which we can do for every project. You feed the total design flow into your loop. So let's say the whole project can be set from your computer by simple uploads. So this is the real feature and benefit of the design flow setting remotely. It's not only one by one, you can set the whole project from same location, as long as you have the communication live everywhere. So flashing in the air, flashing in the air. Okay, if we already set the flow to 50%, in case of, since we allow the forward and backward flashing through the valve, we can flash our valve to clean your coil. So to do the flashing, we recommend, or the valve should be at full open position. And if you have your full project set at different setting, you don't want to go everywhere and open every valve. So once you hit the flashing program, it will disregard your setting for predefined time. And this time, which your example is 60 minutes, is controllable. You can set that time. You can put it 3 days, 1 week, 1 hour. It's set, something you can set. So this is the flashing. Once the flashing is done and the time has elapsed, then it will return back to the original setting. So this is also useful in case of testing or in case of pump testing. You can just hit the flash program, it will full open the system, and then reset the valve again. De-air, this is if you feel like you have some air bubbles stuck inside your valve, then you can hit the de-air to push these air bubbles away from the valve or the coil. So what it will do, it will open and close the valve at max speed for 5 times. So once this is done, if there is any air bubble stuck there, it will go away. Where the vent valves will be opened and it will come out. So in normal installation, you need to install the valve, fill the system, flash the air preset, install the actuator, then close the false ceiling. In case of smart actuator, you will install the valve and actuator, close the false ceiling, and then after, from the BMS, you can do the flashing, the air, and the flow setting. So this will save a lot of time and will reduce the spread of the workload. So you will not find the electrician, pipe fitter, duct installation, everything at the same time. At least you have removed one of the tasks, which is the actuator and valve. As we said, since the actuator is addressable type, there is a couple of alarms that can be provided. Example of that, error. If there is no signal, let's say no backnet, you will have an error, or no control signal, you have an error. If there is, this is very important, error in calibration, which means something is wrong, actuator is not properly fixed, because some of the cases which we see in the sites, that they insulate the valve neck till the thread of the actuator connection. And that would cause that you feel like actuator is fully tight while it is not. Even that 0.2 or 0.3 millimeter gap is detectable because this actuator has a very high number of steps, 1024. So this is 0.01 millimeter is detectable as an error, and it will be alarmed to the user. If there is high, also you will have an alarm if there is a high temperature inside the PCB of the actuator. If there is abnormal power supply voltage, this is also very important. Why? Because you would know where exactly to boost the power. Let's say if you need to boost the power in a loop, we say that it should be every 7 to 11 actuator, you need to boost the power. It might be more. How you find out? By this alarm, if there is abnormal power supply voltage. Also, if the actuator is closing the valve and something is stuck inside the valve, I don't know, anything can be stuck inside the valve during the flashing process, etc. You will have an alarm that you have a closing error due to obstruction. And if there is no control signal, if you are using a local analog control signal and the signal is not there, we will have an alarm on the absence of the signal. So these alarms are useful. There is still more alarms that you can see. It's more status alarm, not errors. And based on the BMS requirement, what they want to see from the actuator, it's selectable. Let's say if the BMS is not yet ready and you need to do something, or the wiring is done, but its BMS is not connected, which is most of the project cases. All these alarm which we were talking about, and the flushing and the movement of the valve, everything can be shown from the local LEDs of the actuator via the color codes. So at the side of the actuator, you will see green LEDs blinking, orange, red. Every combination of colors you can check in the datasheet, you will find it means something. That's why I'm saying if the BMS is not yet ready and you need to boost the power, then if you have your wiring done, energize the actuator, there will be like one red, two green, and one off. That means that power supply is dropping at that actuator. There is your boosting point. So that's simple. So everything, valve position, movement, and errors can be seen from the local LEDs of the actuator. This is, I would say, is a very useful feature because I never seen a BMS interface completely finished during the mounting of the actuator and wiring of the actuator. Most of the case, it is a later stage, and it will be done during nearly the handing over of the project itself. Local control options. You have the reset, the manual override, and the dip switch. So manual override is the manual override, just to move the actuator when power is off. Reset button in case to recalibrate, or in case you are changing the communication protocol from Modbus RTU to BACnet and vice versa. Dip switch setting, it's used for manual MAC addressing, which is not required because the actuator is automatically detecting itself to the BMS, but it is also used to enable the 120 ohm resistance to end the loop, because if you want to close a BACnet loop, you need to enable a 120 ohm resistance to make the BMS knows that this is the last part of the loop. And that dip switch will be a dip switch number 8. So dip switch number 8 is to enable the end of the loop. It is very important. Flow indication, how it is possible. So we are not saying that there is a flow sensor inside, there is an ultrasonic, there is a transducer. No, it's simply the number of steps and the precision of the actuator that will make us say that you can have the flow at an acceptable range compared to a flow measurement device. So here what we say is maintaining constant differential pressure in your system. Since, as we said, everything is connected, the last point in your system with the dip sensor will show you that there is enough pressure in the system. Assuming that across the valve there is the minimum differential pressure, every single position is detectable, which means if we take an example of 2.5 millimeter, if you divide it by 1024, 0.00025 millimeter is the movement. That precision will give you on its own, without the interference of pressure, like 2.5% error. But if you put the pressure on, then it will be 5 to 10% accuracy. But if you take it overall, the flow indication from the Novocon, assuming that you have enough pressure across the valve, is 5 plus minus 5% accuracy. So it can be used to monitor, it can be used to calculate energy, it can be used to control energy, it can be used to control anything. So this is how the flow indication is done in the actuator. So daisy chain, how it will look like. So as you can see on the small actuator, Novocon S, you can loop together 64 actuator. In the medium size Novocon, you can loop 32. And in the large Novocon, Novocon L and XL, you can loop also 32. But if you are looping the Novocon with another BACnet device, because when we say that it's an addressable actuator, which means it can communicate with any existing BACnet device, another addressable device. So this will be counted in the loop. Let's say if you are looping Novocon with DDC, another Novocon DDC, Novocon control, and so on, then the total loop will be 32 instead of 64. And the power booster, in our example here, we're putting 7 to 11, but this is also, you can see it from the local LEDs where you need to boost the power, or you can, if you have the BMS also, you can see that you have an error or an alarm about abnormal power supply. There you need to go and boost the power, which will save you something. But in the project we have done here, most of the cases, every Novocon, they are providing the power for it. It's not, it is not the power supply that they are providing locally from every controller to actuator, because they need to use the local controls. Sticker on the Novocon. Once you have the Novocon from the back side, there will be a removable sticker and there will be a fixed sticker, both having the same information and the QR code. So you can use this unique ID. So one will be on the actuator, another one will be fixed on your BMS drawing. So why you do that, which is very important to know which actuator is used for what unit, and then you can remotely access it, set the flow individually, flash it, do whatever. So this is very important. Before you put any Novocon, you need to, once you install it, you take the sticker and you put it in your control drawing. So having said all these, we will speak what you can use Novocon for. So it is an actuator addressable type. It's not used for every application. It's specifically required for something, which is energy management. So if we talk about the energy management, then we'll talk about built-in alarms in the Novocon and the precision on the Novocon. So if we take the feedback on the energy from the actuator, since we said that it has temperature sensor, it can indicate the flow, then you can track the energy, you can find out what is the consumption, and you can tune that consumption to reduce it. So in this example, changing some of the behavior can give you 10% of the energy saving without doing anything. It's only changing some variable from BMS. So if you limit your power, as we said, Novocon is calculating the power. So you would know that this room was oversized by another 20%, and the unit is selected on 20%. What you can do is limit your power consumption to whatever in the unit minus 20%. So doing so, you will not allow the unit to go above that limit, and this will give you a lot of saving, because you know, limiting the power, whatever percentage is a saving on the cooling power itself and on the total energy. So how the power limiter setup will be? Novocon being primarily controlled by DDC on percentage of valve, which means the feature we are talking about when we say that it can control the power is a complete different feature from the normal control, which means Novocon can still be controlled normally like any actuator with a 0 to 10 volt signal, 4 to 20 milliamps, or from the BMS. And this power limitation feature is something which is extra, and it's a different variable addressed to the actuator. It will not interfere with the normal operation of the actuator if you want to. So Novocon is gathering energy information about the FCU via temperature sensor. Then Novocon will override the control signal when the calculated power exceeds the user-defined energy limit, which means you can use the Novocon as a normal valve to control based on the room temperature and so on, until the moment the power is exceeding the limit that you have set from the BMS in the Novocon. So doing so, it will limit and save a lot of energy. If you do this for every unit, 5% or 10% of the cooling power is directly affecting the cooling energy. It's not like pumping, saving, or delta T, or these savings need to be calculated to affect, but this is directly affecting on the power itself. So the second feature which you can enable, so the first one, you enable the power control. The second is minimum delta T management. So minimum delta T management is also the same way. It will maintain a minimum temperature difference. So the meaning of that, when the delta T that you are setting in the Novocon is measured by the temperature sensor is less than the set point, the Novocon will start close. And it will start close till the point that the delta T is back to your set value. Once it is back to your set value, the delta T management system will be disabled and then back to the same scenario. So it will look like this. Novocon primarily being controlled by DDC or control signal via percentage of opening. Novocon will override the DDC control signal when the user-defined delta T is not achieved, and the valve will begin to close. Novocon is gathering energy information about the FCUs via 2 temperature sensor or about the area where it is installed. It's not necessarily an FCU. So when this is happening, you will have an alarm that if the sensors are connected or not, you will have an alarm that delta T management is there, it is working, and so on. So you would know exactly if you are using the Novocon, let's say in a shopping mall, which we did already, and it starts controlling delta T, then you would know exactly which shop is having issues and bringing a low return temperature to your system. You can tell him that either he's using the wrong solution or he's having a problem with maintenance, maybe his air filter, maybe his coil, something is wrong in his area that needs to be rectified. That's why the Novocon is disregarding the local control and enabling the minimum delta T management. So here is another way to do it, but in the last slide we saw the minimum delta T. Here's the set delta T. The difference is simple. When you control minimum delta T, the moment you achieve the minimum delta T, you will release the control back to the thermostat or the DDC controller or the BMS. So the normal, once the delta T is achieved, you will have the normal operation. Then you will see like oscillations in the delta T, ups and down, but the average delta T will be there. When you make set delta T control, it will respond to only the delta T variable. So Novocon will not accept the DDC flow control and will only maintain constant delta T. This is useful when you are putting a Novocon on a branch and you need the predefined delta T and that's it. So this can be used as well. So how it works? It's primarily controlling itself and overriding the DDC bus control signal. So the Novocon, when you are set the minimum delta T, it is not controlling via, normal thermostat or via the BMS. It's controlling only based on the minimum delta T. So based on the application, it's flexible. You can choose any of these type of control sequence. Another feature also is the minimum return temperature, because as you know, when you try to control delta T, what is the downside? the supply temperature might increase, and in some area you might see some discomfort. If you have doubt on how suitable is your supply chilled water temperature, is it low enough or it is high, or so if you have a doubt on that, you can only go and set the return chilled water temperature. Let's say regardless of what I am having, I would just set the return temperature to 14.4 to achieve the district cooling requirement and not to have some surcharges. So in this case, the Novocon will adjust itself to maintain that return temperature only. So how it is done, it's simple. Novocon primary controlled by DDC or local control, thermostat 0 to 10 volt, percentage of opening. It will override the DDC control signal when the user defined return temperature is not achieved. The valve will close accordingly. And the temperature data is gathered from the temperature sensor as well. Same way, alarms will be there when this is happening. Also, the unit of the energy can be changed, kilowatt, megajoule, and then MBH as well. Set return temperature. So we said one is minimum return temperature, one is set return temperature. The difference when you see minimum and set is in case of minimum temperature control, the moment it achieves, it will release the control back to the local controller. If it is set temperature, it will only control based on the temperature. And as you can see here, Novocon is primarily controlling itself and overriding DDC bus control signal via in percentage of opening. So you might ask why you need this and why you need that, because let's say take an example. If you will be using this actuator on a pipe branch, you don't need, there is no local control, there is only BMS control, and you need to maintain the delta T on that. So you enable set delta T control on that branch, and that's it. But if you are using the Novocon to control a unit as a normal operation and you have doubts on what will happen with the delta T, then you can make minimum return temperature or minimum delta T control. In case of that minimum delta T or minimum temperature control, you will maintain the local control, which is via thermostat or BMS locally, plus you will be able to control based on the delta T in case it's dropping below the set point. So energy management, here is another feature that it can be useful if the BMS, they are seeing everything. So how this is done, how you can optimize the chiller, since we said that you have the temperature sensor on the Novocon, and then with the delta T control, energy limitation, energy count, which are all our features inside the Novocon, you can, let's say, find out up to which temperature you are not affecting the comfort level. Let's say you are achieving the comfort level with 5.5 degrees supply chilled water. Now, you are increasing from the chiller to 6.5 because you have the data on that area. Every area is connected, communicating with the Novocon. So the 5.5 can be 6.5, can be 7.5. It's based on how is the peak load condition, if it is part load, full load, etc. So the temperature can be increased, and you know, if you increase the supply temperature, you reduce the energy consumption of the chiller. How you can do that only by seeing what is the effect of increasing that temperature on the zones. You will end up with one position to trim the chiller to your optimum, most optimum supply temperature. And you know that half degree in the supply will make really a big difference in the energy consumption. So let's say if the room is 23, outside is 35, the supply can be changed because this is different than if room is 23 and outside is 46. So as you can hear what I was talking about, increasing the set point, it was 712, it became 8. And then if the room is still okay with that flow rate, then 8 is okay. Delta T is still met. And the effect is really big. 1 degree increase in the chiller temperature, increase the coefficient of performance. This is also one of the features which are built in the Novocon and which is important while we are controlling and maintaining minimum temperature, because as you might know, when you are using Novocon with the ABQM in normal control scenario, 0% or 0 volt or full close command will give a full close command. But while it is controlling energy, controlling return temperature, controlling delta T, in order not to affect the comfort level, we designed the actuator to close up to 10% while the actuator is controlling via the temperature sensor built in and maintaining a minimum delta T. Why we did that? For the simple fact that if you close, you will affect the comfort. If someone is misusing in a loop and you are using Novocon to maintain delta T, if 1 or out of 5 are having issues and you close, then you are affecting all the 5s. But if you gradually close and you limit to a minimum opening, then you will not affect the overall comfort level. Now, sometimes this 10% minimum opening is high, and you cannot change that if you are using minimum delta T control or minimum return temperature control. How this can be done? By this alpha value. So the alpha value originally is planned to be changed in order to change the curve. But as you know, if you have water to water exchange, you need linear. If you have air to water exchange, you need equal percentage. But the curve will look like this downside curve, dotted line. So for me, if it was fully linear and then the 10% will give me 10%, but if it was at equal percentage, the 10% will give me 5%. And if I change this alpha value into 0.1, then the 10% will give me 2%. So the minimum opening of the Novocon can be changed based on the application, but it cannot be disabled as long as you are maintaining delta T and controlling delta T, because it has to be there. There should be a minimum opening in the Novocon in order not to affect the comfort level while maintaining or controlling the energy. So this is really important point to talk about. So we came to the conclusion. Novocon adds value, faster design with ABQM, faster installation, faster remote commissioning, energy optimization, faster problem allocation, faster remote maintenance. Novocon also saves time by remote system verification, wiring to the actuator, connection to the valve, valve resetting, valve operation. No need to visit the site, which is very important because some of the places are really not accessible at all. So the remote status feedback and the local status feedback are important in these cases. This is it from my side. We are open now to the question.
Thank you, Anis, for your presentation. We will go ahead and take some time for questions now. So first question is, what is the length of the cables and what is the type of the material of the gear?
Type material, gear material are hard plastic, which are the same used for any gear actuator, small size. Now, if you go to Novocon large, which is used in ETS rooms, material is a stainless steel for the shaft and gears. But anything else will be the hard plastic, which having a lifetime of 150,000 cycles, and 150,000 cycles means more than 15 years. So the material here is really designed to last the lifetime of the valve actuator. For the cable length, this is based on the BMS. If you are, as we said, you are looping the system to each other, you can go as long as you want until the moment you have a drop in the voltage, you will boost it again, and so on. But let's say, if I would say 500 meters, I would say more, it's up to the project design itself. But when you increase the cable length, if it is the backnet inverter, non-inverter, there is no big limit because it is not getting affected by the resistance of the wire. But if it is power supply, it will be affected by the cable length. Now, the moment you will have issues in power supply will be the limit of the cable length. Let's say it will drop after 150 meter. If you are telling to me from one actuator to another will be more than 100 meter, then yes, the cable length is a question, which is valid. But in most of the loops, every actuator is close to another actuator, so there will no be problem in cable length. But as we said, it's carrying the power supply from an actuator to another. I would say 150 meter is the limit from an actuator to another. Otherwise, you need to use a signal filter to maintain the same power supply from two actuators. Was that answer clear?
I hope so. Can we remove the BTU meters from the system if we are using Novocon with the flow indication and temperature sensors?
It's based on what is the usage of the BTU meter. BTU meter is an energy calculator. It will gather supply and return chilled water temperature like the Novocon do, and it will measure the flow with an ultrasonic flow meter or magnetic flow meter. Okay, so it will at the end show you a flow rate and an energy. In the Novocon, it will show you flow rate and energy with one single assumption, which is the pressure to the system. If your pump is pumping enough pressure to every point in your system, then yes, you can use the Novocon as an energy indicator instead of the BTU meter. But if you are not sure, then this is a flow meter or in a BTU meter. This is a Novocon with energy indication, not to confuse. Okay, so you can use it by assuming you have everywhere the minimum differential pressure required by the system.
Okay, next question is, what is the maximum size of the valve?
As you know, Novocon coming for every single size we have as of now. So we have Novocon S, which is used for sizes up to the N32. You have then the Novocon M, which is used for sizes the N40 up to the N100, and then you have a Novocon L, large Novocon, which is used for the N125 and the N150, and then the last thing you have Novocon XL, extra large, which is used for the N200 and the N250. So the L and XL application is specifically for the district cooling, because in district cooling ETS rooms, you might not need PLC anymore, I would say, because built in the actuator, you have the ready program and sequence of operation to open and close your valve based on a temperature. So the remaining of the alarms that you need, let's say the DP transmitter across the strainer, which will show you if the strainer is blocked or not. This is one wire which can be linked to the Novocon and remotely sent to the main plant. It's based on the distance between the main center plant and the ETS room. Or the size of the building itself, because I know in some district cooling providers there is buildings that using district cooling with 7 floors, with 10 floors. Those buildings really that there is no big, or I would say, need for a PLC. It can directly be standalone controlled by a Novocon and a large ABQM valve. So yes, we have the full range from the smallest to the biggest. All actuators are available for all valve sizes.
Next question is, do we need additional temperature sensors for delta T control?
No. Whatever you will be having with the Novocon, there will be two temperature sensor. For the small size Novocon S, you have built-in 2 temperature sensor. For the medium size Novocon and the large and X large Novocon, you have a 3 temperature sensor provision. You can use one for supply, one for return, another one it's free. You can put on the return air, you can put whatever. So yes, you don't need extra temperature sensor to control delta T from Novocon. It has its own.
Okay, next question. Any solution to remove individual FCU controllers from BMS F3 speed fan other than EC motor fan?
Why I spoke about the EC fan motor, because of the output from Novocon is 0 to 10 volt. And this output can be linked with the sequence of operation, which means I can tell to the Novocon to make this 0 to 10 volt, make it 5, if the temperature on PT1002, the temperature sensor 2, is going 22. So I will reduce the speed if the temperature is, so what is making me doing this is the sequence of operation that I want to achieve by removing the controller and using an EC fan motor. So that's why I was saying about only EC fan motor. But in case of a 3-speed fan, it's a relay and it's 230 most of the time. We don't have output from Novocon as 230 to control that, and we don't have the sequence of operation to control it. But what I can mention about this, which is also, it might save money, the Novocon can be pre-programmed from Danfoss at the factory to be a standalone delta T manager, which means I can set that the Novocon will be responding to your room thermostat up to the point where your delta T is less than the design value. Let's say I will tell to Novocon respond open, close based on the room temperature. The moment the delta T is dropping less than 7.5 or less than 8, you disregard the thermostat control and you will control on your own to maintain that delta T. Once it is maintained, then you will release back the controls to the normal local analog or thermostat control. So this is very nice feature because you don't need BMS for that. You can just ask the actuator to be ordered pre-programmed to maintain delta T in the project. And if you take, like, this is really a simple calculation, 1 degree less on the delta T is 7% of the bill. If you take, let's say, 2 or 3 degrees, that's a huge amount. Now, if you compare the cost of a normal actuator with thermostat or Novocon pre-programmed to maintain delta T, the payback time is less than 1 year if you consider a standalone. But if you link it with BMS, with the looping, with, then it will be more expensive solution, and you need to select which area to use this Novocon. In shopping malls, we use it everywhere because it's most of the time linked with the owner. But in case of residential building where the delta T is really crucial for the overall consumption of the building, then yes, a solution can be there, which is to make a Novocon as a standalone delta T manager. So you will not have the monitoring feature, but you still have the energy management feature. But monitoring the feature can be there if you want to locally visit the Novocon. You can link with our configuration tools and see all these variables live in front of you.
Okay, next question is presetting is not required now as it's done by Novocon.
Presetting is not required. Yes, you don't need to set the valve. You keep it 100%, 120, whatever setting you will keep. It is now, it can be recognized by the Novocon, and you can change that setting. So in case you have a doubt, let's say when the Novocon is fixed on any valve, the first thing it will do is the auto calibration. When it will do the auto calibration, it will show you the actual stroke length of that valve. So instead of, let's say, if you have issues in setting the valve, or it's a used or it's a retrofit, you want to put this Novocon on an existing ABQM, then you can make a user-defined valve and you can set the stroke length. You don't have to set the flow, not to confuse. You will say that I need to limit my stroke to that limit, and that's it. So it's flexible. You don't have to set mechanically anything. Even the model of the ABQM, which is used with the Novocon M and L, will have a different neck because there will be a spring, and also there will be no scale to set the flow, and there will be a different override of the flow setting mechanism, which we are keeping only for a safety feature. So yes, from the Novocon you set, you don't need to set any single valve.
Okay, next question. How to ensure the correct flow for different delta P reading while there is no delta P transmitter?
Yeah, because it's a PICV. So when we say PICV, from a starting differential pressure, the flow will be constant, because in a pressure independent balancing and control valve, you need the minimum differential pressure to achieve your design flow. Any excess of differential pressure coming from the system will be taken care by the differential pressure controller, and the differential pressure controller will react and close to maintain the same constant differential pressure across the control part, which is connected with the Novocon. So how to ensure is the job of the mechanical part of the PICV. That is how we ensure that the flow is correct, because anything above, let's say the minimum is 16 kPa, from 16 kPa up to 600 kPa, the flow is constant, and we have a performance graph for this using the Novocon or using a normal actuator. So if it is less than 16 kPa, the flow will be less, but if it is more than 16 kPa, the flow is the same. That is the work of a pressure independent balancing and control valve. So yes, it is assured as long as you are having the minimum differential pressure or higher available across the valve.
Next question. Can we mix Novocon with the standard actuators? If yes, what is the impact?
You can mix Novocon with a standalone.
With the standard
actuator.
Standard.
With the standard. Yeah. I mean, Novocon is communicating using BACnet or Modbus, BACnet or Modbus communication protocol. So if you are using Novocon, either you, as we said, you can use the local control like a standard normal actuator, or you can use BMS control, or you can use both. But when you use both, you need to tell to the BMS to enable both controls. Now, mixing together Novocon and standard actuator, it's not like can we. It have to be, because if I take a normal building, I have areas like residential which are standalone. You will have a normal standard actuator, locally controlled, 3-fan speed motor, etc. It is not connected to the BMS, but the common area is connected with the BMS. The common area is connected with the BMS. You will be using the Novocon. So here you have a mix between Novocon and standalone or standard actuator. So yes, you can mix with no effect on performance on both actuator. Both will be fine.
Okay, next question. Can we set design delta P on Novocon?
Delta P.
Yes.
Maybe in the future, we are trying to find a differential pressure sensor small enough to be built in or to link it with Novocon. Our R&D are working, but you cannot set minimum differential pressure. But if you have the sensors installed already, and the output of that sensor will be in terms of 0 to 10 volt, then you can use that to control anything. And the information can be transmitted through the Novocon to your BMS. But from the Novocon to measure delta P, not yet available. We are trying to work on this picture, but it's not something that is really, because differential pressure electronic pressure transmitter is a bit bulky. But if the information needs to be any information that you want to see in your BMS, you can just link it with the nearest Novocon locally, and you can get the information in the loop.
Okay, next question is what is the maximum flow rate available, and what's the accuracy of the flow and temperature?
temperature accuracy is a pity thousand. That is no problem at all. Let's say the difference in the temperature accuracy is if you are using a immersion sensor or if you are using a surface sensor. If you are using a surface sensor, you will be having like half degree difference. But since you are controlling supply and return or temperature difference, the half degree from the supply, half degree from the return will not affect the delta T. Now, for the accuracy of the flow control, as we said, if you take an energy meter, move the Novocon, and see what is the flow accuracy, it's less than 5%. It is controlling the flow. The accuracy of controlling the flow is less than 5%. Accuracy of indicating the flow is 5 to 10%, which I was talking about, because this is depending on the system differential pressure. Now, the maximum flow that you can have with the Novocon up to the XL version is the 407 cubic meter per hour or 407,000 liter per hour. This is the maximum flow. Minimum flow, as you know, is 30 liter per hour, smallest size. So as we said, we are covering the full valve sizes. By the end of the year, the XL will be available. So the flow rate is up to the N250, as we said, which is 407,000 liter per hour.
Okay, Anis, thank you. I think that's it for questions. I hope that you enjoyed the presentation. If you have any question, you can contact me or any other colleagues from heating department. Next week, we will have a presentation about the thermal balancing for domestic hot water. You will receive an invitation for the same. We wish to see you there. Thank you and have a nice day.